Hi everyone, my name is Dr. Antesar Shabut. I am a senior lecturer in computer science and I am the program leader for BSc Computer Science at Leeds Trinity University. I am very pleased to be with you today to present AI for all kinds of minds. I will be covering the basics of AI and how you will find your way to get involved with this new technology as either a contributor or a receiver. AI has been around us in every aspect of our life, including intelligent personal assistants such as Cortana, Alexa, and Siri, and many other examples such as recommender systems and social media platforms. But what is artificial intelligence? What is AI? What other concepts which strongly associated with this term? Artificial intelligence or AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions, while machine learning is just the concept that a computer program can learn and adapt to new data without human intervention. You can see another subset here, which is deep learning, which is the subset of machine learning that can deeply learn and adapt to new data as well. And it is getting popular nowadays and being the main algorithm used in different intelligent systems. AI today can be just seen as a subset of machine learning. Machine learning systems can do lots of things. They can play board games and compete with professional players, including known games such as chess, Go, AlphaGo. Machine learners can recognize a human voice and they can, for example, classify data as a cat or not cat, check what is in a picture, and many other things that machine learning systems can do. But what is AI task? What we need actually just to be an AI system to do. In this example, we need just to give some information as input and we need a recipe which can generate an answer to a question. In this slide, the question is whether the image inserted into the system can be cat or not cat. So we need to have a recipe to do that. The question in here, can handwritten programs can do this, can work in this situation? Then how might you approach to solve this problem without machine learning? What challenges would you encounter to do this? The simple answer is just it is complicated. It is not actually possible to do this easily using hand crafted programs or traditional programs that we know before. And this is just machine learning comes in place to solve this problem. Just to reinforce the point here that a handcrafted program is highly unlikely to succeed here, given complexity and variety of images. Our brain does this so easily, we don't even think about the of what it is doing. But then our brains have been fed a huge quantity of cat images over a lifetime, which is just we develop a trained vision model in our brains. As we try to model a solution for real-world problems, then some of these problems are too complex to model and solve algorithmically, as in programmer, for example, define the procedure for solving the problem, and then it comes in place the deep learning and neural network together to help us learn from examples in order to solve these problems. The solution is to streamline and automate complex processes, but how we can do this, we need to teach computers by examples. We need to cover a variety of images, for example, of cats, to make sure that we have a better recipe to answer our question. We just said in deep learning and neural network, we come together to solve complex problems in AI and also to provide better solutions. Then AI in future can be just seen as a subset of deep learning. But what does it mean to be an AI developer? Is it the only role that you can play in this field, or there are other roles which can be played? Of course, there are other roles that can be played, but let's see in this slide focus on the role of the AI developer. The first problem that we showed throughout previous slides is the complexity of a human process, and then automating those processes will be complex as well. And also we had some limitations due to computational constraints, and also developers, they learn how to solve problems with different way, and they need to change their mindset to use AI and machine learning. But still we need some good skills to be AI developer, or to just be a contributor to this field, including programming languages and linear algebra and statistics, and also signal processing techniques and neural networks. Developers or contributors need to understand machine learning and understand that machine learning is just an approach to make lots of small decisions on data. And then, for example, who's eligible for next day delivery, who is for example, what is my house price in 2030, who is likely to commit another crime, and another question could be who actually hears about career opportunities in tech industry. Machine learning is about labeling everything, just labeling the data, and learning the recipe from the data. If we compare this slide to the previous slide, Lane's AI task, we can see the changes in here. We changed the information with data, and we changed the recipe with machine learning model, and we replaced the answer with results. And this is just what we can do in any intelligent systems. We need data to start with, we need an algorithm to build the model, and we need to have the results. So if we need to start with machine learning tasks, then we need to follow some sort of steps which explained in this slide. We need to start with the problem and collect example data, raw data and spreadsheets, and we need to identify something called features in the examples data for handcrafted features, or use deep learning for the automation of feature extractions. And then we need to label your data with correct labels. And finally, think about animal approach or algorithm based on your labels to get the result back. We can classify the problems in machine learning into different problems, whether it is a classification problem or prediction problem. Classification problem can be divided into two parts. The first one is just binary, which is two classification or two categories, whether for example in here, cat or not cat, dog or not dog, and then multi-classification. For example, if we have different animals to classify, like for example cat, dog, bear, giraffe, elephant, or it could be prediction or regression, which is deals with numerical data. But what are the main types of machine learning? Then we have three main types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is just to teach me what to learn by providing all the labels. Unsupervised learning, just I will find out what to learn without the need of labeling the data, while the last type in here, reinforcement learning, I will learn from my mistakes at every step I have, which is just to take the concept of hit and trial. But what is supervised learning in a simple term? That we need for each example or data sample, we need to have the correct answer or label in this situation. For example, the machine learning model we need is just to say or to answer the question, is this cat or not? Then we need to just have some examples, many different images of cat and not cat images, and then we need to label every image we have. Then we need to have the features, and then the features fit into the model, and the model will learn from the features and get the answer into cat or not cat. Then the main thing or main takeaway from this slide that we need label for each example data we have. Of course, after training your model, you need something is called testing your model, which is include for example, the new data, like for example, if you put any other image in here, and then the model should be able to predict the correct answer. For example, here, if we just put this image, the model should actually just answer not cat. It is too dangerous maybe if the model can answer this way, this is a cat, because this if the model for recommending pets for home, then this model will actually provide dangerous results. But there is a question here, for example, how could you just judge how good a model is? Take a few minutes to think about this and write your answer. Another thinking point in this, how could you make it better? How you can just improve the performance of any trained model. This is the second type of machine learning, which is unsupervised learning. Here, the labels are not predefined. Labels are assigned through cluster analysis and might result in different or unexpected groupings compared to supervised learning. In this example, reinforcement learning, or in this type, here the system learns from the environment. There is a sequence of action which can be followed like playing Atari game. Learn by time through reward and punishment, which designed by researchers, and it is the most difficult and needs researchers to build such a system. Need to understand the difference between data science and machine learning and what is the use of both. For example, if you want just to get inspired of data, and then there is no decisions or just a few decisions and answer can be found in the data, then this is just called data analytics. Then the next thing is just the use of machine learning, where you need to make recipe as we have explained it in the other slides, and then the learning should go beyond the data, and you will have many small decisions on future data, while the other discipline or other area is just called statistical inference, and this is you need just to decide wisely, and you need to have some sort of conclusions on data, and this is would help to just make critical decisions. In addition to knowing which area you are working on, for example, as we explained in the previous slide, data analytics, statistical inference, or machine learning. For machine learning, you need to have data and lots of data. So ML cannot work without data and hardware to process this data. Just a thinking point in this slide, what are the implications of this need for data and processing power on how we implement machine learning in software applications, and you need to think about different things, work practices, platforms, tooling, and also expertise and culture in any organization. We'll look at the implementing machine learning in industry. The primary goal of machine learning in industry is just to automate and enrich decision making, as we just explained, by exploiting the knowledge inherent in data. This goes hand in hand with the fact that companies either have or are acquiring lots of data and they want to use it to get ahead of the competition. The typical flow involves acquiring data and producing a predictive model. When implementing this flow, we aim for as much automation as possible, version control, regulations where needed, example to approve things to proceed, and to monitor the flow of the AI and how it is doing in practice. Just to know how to develop a machine learning model, you need to go through different steps. We already just explained some of these steps when we went through the supervised learning example, but in general, what you need to do to just implement and monitor machine learning model, you need to have different stages, include data extractions or feature extraction, and then data exploration, model training, and then when you have the model, you need to deploy it and it should go for live production, and then you need just to test the model. Testing could be just on different stages during the training stage, and also during the production stage when we have the model live. Then what you need to do, you need to test the model when it is live, and the model can actually just drift and need retraining, and we need just to feed this into all the stages back from the data extraction or engineering, going forward to data exploration, and again training the model. Artificial intelligence and machine learning is not just something that mathematicians or computer scientists can do. There are lots of roles that make it up the end-to-end process from data to working ML model, which you can see, for example, people working at different stages. For example, at data extraction or engineering, you could just work as data engineer, or Excel fanatic, or even a database administrator. And also at data exploration, we need data scientists and business analysts to understand the data. At ML training, you could work as ML engineer or researchers in AI or ML. And then for the deployment, you could just work as cloud engineer or infrastructure engineer, software developer, or even website developer to deploy the model in a web app. And then at the final stage, you could just you work as a site reliability engineer and operations engineer. So lots of roles just around the use of AI and ML, and you can just get involved in this advanced technology by exploring these roles. If you go to this link, which is appears in here, you will find two examples for you to practice. Then please feel free just to go to this link and practice the examples. What you need to do is just to run the code, block sequentially, and discuss the questions with your partner. Same for the example 2. Completing the exercises, we came here to the retrospection slide. What surprised you in this presentation? What made you curious, and what next for you? Are you going to just look at AI and machine learning for your career? Are you going just to look how AI will be implemented, or how are you going to just learn more about data science? It's your choice and what you need to do with this knowledge you have developed. In these slides, we will just give you some takeaways. For example, in here, ML gives us a way to automate decision making by exploiting the knowledge inherent in the data. The problem machine learning is good for are those which would be too complex to solve, and then machine learning comes here to play. It is part. AI and machine learning, is it just something that only mathematicians or computer scientists can do, but many other roles could be involved in this field. Machine learning is just increasingly used by industry, and there are many associated roles. If you are just interested in learning more about ML, the best way is to have a go. And here is just a list of resources used to develop this the presentation, and please feel free just to access any of them. Just say thank you, and I hope you enjoyed listening to this presentation and you learned something useful from it.